So, good morning. We have discussed about the high voltage generation, which is very important for the testing of high voltage equipments in the laboratory. So, essentially we have looked into the generation of high AC voltages, high DC voltages and high impulse voltages, both impulse surges of both voltages and currents. So, these are very essential so that the available generators could be used for the testing and also proper verification of the equipment which could be installed in the high voltage transmission network or in the substation. So, generation of high voltage is equally important, is also the measurements. So, measuring the high voltages for low voltage you have several equipment or the oscilloscope or any other measures where you can be used for the measurement, but in case of high voltages and high currents particularly in the range of hundreds of kilovolts and hundreds of kiloamperes. So, the measuring equipment plays a very important role in the laboratory. So, we will focus on some of the important measurements which are typically used for the high voltage AC, high voltage DC, high voltage impulse voltage and impulse currents. So, we will focus on some of the important and the importance of the measurement and the equipment or the measuring systems which have been deployed at the high voltage laboratories for the same. The first and foremost important for measurement of high voltages is to see that any high voltage measurement laboratory should be able to use the devices. So, measurement of peak values, it could be of high voltage AC, HVDC or both type of impulse voltages. This could be done by the use of a spear gap arrangement. So, the measurement of effective values of HVAC and HVDC is also being done by using electrostatic voltmeters. Measurement of AC and DC and impulse voltages is done by using the dividing systems. It could be resistive dividers or a capacitive divider arrangement. The measurement of AC high voltages could be also measured by using a peak voltmeters, and finally, in the recent past optical measurement systems for measurement of high voltages is also being used in the laboratories. First we will look into the importance and how the peak voltage is measured by using the spear gap arrangements. This was one of the important method which was being used since the high voltages were known, and this is the simplest method where it can be used in the laboratory. So, basically consisting of two adjacent metal spheres and placed at a equal diameter. So, these spheres have to be of the same diameter and arrangement could be of a vertical or a horizontal arrangement, and the separation distance is limited. So, for a spear gap for measurement of the peak value, you can either measure AC, DC or both type of impulse voltages using the spear gap assembly. So, the basic mechanisms of high voltage measurement by spear gaps is done by applying the voltage, and the breakdown voltage of the distance which is maintained between the sphere, that is the air gap. In uniform field, the spheres are of uniform dimensions and uniform field will be obtained by using the sphere gaps. So, the breakdown voltage of the air gap in uniform field is again determined by the gap distance. So, the diameter of the sphere and the gap distance play a role in the uniform field breakdown voltage. So, this is a typical example of the arrangement of sphere gap vertical sphere gap assembly, where it is being used for the peak voltage measurements. So, this assembly consists of the following. You can see the two spheres are here. So, the sphere, one of the sphere is connected to the ground end, which could be a mobile, it could be one of the sphere could be on a mobile platform, other is normally fixed. So, the two sphere gap arrangements are fixed to the insulating support. You can see that this is the insulating support. The second, here you can see the sphere shank, the metal sphere could be of copper, brass or aluminum. So, this sphere shank again is a metal portion which is connected to the insulating support. So, this is the shank, this is the insulating support. Third is this arrangement where it is an operating gear showing maximum dimension. So, the distance S between the two spheres can be controlled by using a motorized mechanism in case of the huge spheres. So, this is basically a control or an operating gear arrangement for the making the arrangement of required gap distance. So, the high voltage connection is given here with the help of a sphere with the help of a series resistor. This high voltage connection is shown, it is connected to a metallic end of the shank, and we have a series resistor. This series resistor is important in case of the flashover, the pitting on the resistor spheres is avoided, and also the following flashover, during the flashover the current will be limited to the source. The connection which is made to the high voltage terminal is known as the you see a small ring type of arrangement here. This is a stress distributor which is connected between the metallic and the insulating rod, which shows higher dimensions than the shank of the sphere gap. The P is, you can see the point P here, P is the sparking point. When the voltage is applied, the spark occurs between these 2 points. So, known as the sparking point in this sphere gap assembly. And distance from the ground, this is the ground plane, from the ground plane is the distance A, which is fixed, or it could be adjusted as per the requirement. So, here shows the height of the P, that is the point where the sparking could occur from the ground. So, the radius, this B, which shows the value from the peak point of the sphere to the outer circumference, which is shown here in the dotted line, represents the radius of a space, this entire space surrounding the sphere gap from external structures. So, it is advisable the external metallic structures should not be near within this in the vicinity of the sphere gap assembly. So, minimum radius of mentioned as per the standard is being followed, and this shows the distance which has to be minimum clearance has to be maintained. Then X, you can see the dotted line here, spherical type of arrangement is shown here. This X is the item 4 which this connection, that is from the high voltage connection through the resistor, it should not pass, that is it should not the contact should be firm and it should not come in the way of to pass through this plane within a distance. So, that this again same distance has to be maintained. So, this distance B is equally should be maintained and it should not come in the vicinity of this clearances. So, this figure peak volt measurement by spear gap assembly, that is a vertical spear gap assembly indicated is for spear gap of 100 centimeter gap radius at a spacing. So, all these dimensions which have been mentioned are with a reference to the 100 centimeter spear gap radius. So, very clearly the dimensions have been given. This is taken from the standard IS and ISC standards for measurement of peak voltages by spear gap. It is available, it is very clear the distance or the fabrication when it is being done for the spear gap assembly, the dimensions are been very clearly given here, the distance, the diameter of the shank, the example here, the minimum insulator dimension, the dimension of the spear, the distance which has to be maintained and the gap, and also what is the minimum diameter of the spears which could be used up to a particular voltage. So, this information is very clearly defined in the standards pertaining to the spear gap assembly is used for measurement of both high voltages and high currents. So, what is the minimum clearance? We have seen about the spear gap assembly, this is the vertical spear gap assembly which we have seen. This is in case of the horizontal. So, spear gap arrangement could be of horizontal or vertical in nature for the measurements of the voltages, and it depends which type of arrangement to be used depending upon the level of voltage which is to be measured. So, here you can see the clearances as per the specifications given. The minimum clearances are defined here, that the A being the clearance from the ground to the point of where the flashover could occur on the top surface. The B is the minimum radius for the clearance required. So, you can see from the table where it gives the diameter in mm, this is a spear diameter, that is the diameter of the spear in mm ranging from 62.5 to 2000 or a 2 meter spear gap assembly. So, here the minimum value of A, that is a clearance from the ground, has to be maintained. In case of 62.5 mm dia spears, a minimum of 7D. So, 7 into the 62.5 is the minimum clearances to be maintained for the from the ground, and the maximum is specified as 9D. So, anywhere between 7D and 9D is the distance which has been given for the A for 62.5 mm dia spears, and minimum value of B. B is a clearance which we mentioned discussed, then the point to the minimum clearances is the distance. This distance is again 14 into S. 14 S is the gap distance. Suppose the spear gap assembly is used for say 2 centimeter gap measurement, if the fixed distance is 2 centimeters. So, 2 into 14 will be the minimum clearances as per the standards to be maintained, so that no metallic objects or any other interference object for the measurement should not be near the vicinity of that distance. So, similarly, when you increase the spear diameter, so you can see the values also change. For an example, for a 2 meter, that is 2000 mm spear gap assembly, the minimum value will be 3 times of the D, that is 2 into 3 6 meters. So, the A will be minimum 6 meters from the ground and the maximum value will be 4 into 2 8 meters. So, 6 to 8 meters will be 8 meters will be the maximum value which it could be taken, or minimum has to be 6 meters. So, this is the clearances required and maintained for the accurate measurements as per the standards, else there could be erroneous results if the deviation is made in the clearances. and the minimum value of B fixed for 2 meter is 6 into the again gap distance which used for the measurement. So, peak voltages measurement was a concept which was initially being used, and even till date for the calibration and measurements spear gaps are also being used in the laboratories, high voltage laboratories and the testing laboratories. Few observations on the use of spear gap. It is advisable to see that excessive pitting on the spears have to be avoided. During the breakdown, continuous breakdown, there could be pitting near the edges on the spear gap. It could be here or here. These have to be properly seen that the pitting never appears, because this again the values which could be obtained will be a different in case the pitting is excess. So, there should be a protective series resistance, that is the intention of going in for the series resistance, that is as shown here, may be placed between test object and the spear gap. So, for case of AC or DC voltage measurements, typical value for the protective resistor may range anywhere between 0.1 to 1 megohms. So, depending upon the values or depending upon the AC or DC, typically the range could be anywhere between 0.1 to 1 megaohms. For impulse voltages, the specification says or it is to be maintained, it should not exceed 500 ohms the series resistance, and its inductance particularly it could be the lead inductance or it could be the resistance which is being connected, should be very small, and it is being specified it should be less than 30 micro Henry. So, what are the factors which could affect the proper measurement of the spark core voltage by using the spear gap assembly? Again, this has been represented here for the horizontal assembly. D is the diameter of the spear, S is the distance between the two spears which is used for measurement. Similarly, for the vertical arrangement, D is the diameter, S is the distance between the spears. Okay. The factors which could affect the spark core voltage of the spear gap assembly are the nearby earthed objects. So, any metallic objects or earthed objects, if it is near the vicinity, that is a factor B which we were discussing. So, this minimum clearance is B from the point of the discharge activity where the could happen to the minimum clearances is of utmost importance, that is a distance into the clearances is very important, else the readings could be erroneous. So, second, so the any earthed objects or metallic objects or any interference should not be in the vicinity of the specified distance. The second is the effect of humidity and air density. So, spear gap measurements have to be taken in where humidity should not exceed a certain value. This is clearly given in the standard where it says above 85% of the humidity, these readings are prone for erroneous. So, repeatability could be not achieved. So, it is always recommended to see that the humidity level and the increase in the air density is of important while using the spear gap assembly. Then it also affects with using the polarity, positive or a negative polarity, and the results are not very consistent. So, it depends upon the polarity values. There could be a minor change in the magnitude of the values with the effect. So, the effect of polarity is also being seen. Then the influence of dust particles, as these spear gaps are of open type where the metallic spears are likely to be influenced by the settlement of the dust particles or on the surface of the spears. So, this could initiate early breakdown and the results which are obtained may not be the correct values. So, proper cleaning is required on the spear gap assembly. And the final factor which could influence is the effect of irradiation. So, irradiation also will influence the spear gap assembly. So, it is always suggested proper UV radiation at a distance could be used to see that UV radiation will help in uniform or breakdown could happen with the effect of proper irradiation. That is one point which is very important. So, limits of accuracy of the measurement, the spear gap arrangement. So, measurements are values which you get either in horizontal or a vertical type of arrangement are normally dependent on the ratio of gap spacing, that is this gap spacing, that is S between the spear gap assembly to the diameter of the spear. And here the error, in case the distance between the electrode is less than 0.5 d, the diameter of the spear, say 2 centimeter dia spear, in case if it is the distance is maintained and such a way that it is half the diameter, then the results obtained till half the diameter of the spears, the gap spacing where is equivalent to half the diameter of the spear, that is the radius of the spear. In such case the accuracy could be obtained up to plus minus 3%. So, whereas in case if the distance between S, that is a gap distance, and the diameter of the spear is of more than 0.75 d or more than greater than 0.5 d, then the accuracy will go higher, will be again plus or minus 5%. So, you may not get very accurate results. So, you will have to be using the spear gap assembly lesser than the specified 0.5 diameter of the spear. So, for the breakdown voltages, proper and necessary atmospheric corrections have to be made because these values could differ from the laboratory to laboratory, and hence these breakdown voltages have to be properly corrected to the standard temperature and pressure values which have been given in the standards. So, there are national and international standards, that is IS 2071 and also IEC 60060 high voltage test standard, where very clearly mentions about the correction factors to be used for the breakdown voltages obtained using the spear gap assembly. So, the breakdown of voltage, as we know, that is affected by air density and also humidity. By applying the suitable correction factor, the breakdown voltage measured during the test condition is to be converted, values have to be converted to that which could have obtained under standard temperature and pressure. So, very important, we have the values to be converted in with equivalent to the standard temperature and pressure which is mentioned. The standard temperature is 20 degrees centigrade T0, pressure being 760 mm of mercury Hg, and absolute humidity at 11 grams per meter cube. These are the standard values which have been specified. Now, considering Vm being the peak value of the measured breakdown voltage of the spear gap, when the voltage is applied, there will be a breakdown here. So, this breakdown voltage for a specified gap is the value Vm, which is known as a measured breakdown voltage. So, the V naught is the peak value to be at standard temperature and pressure. So, we have to convert the values to the standard temperature and pressure. For this, we have a correction factor to be used. So, that value V naught, which could be equal to the peak value at standard temperature and pressure, is given by Vm by K factor. So, Vm is the peak value of the measured breakdown voltage by a factor K. Again this K is equal to K1 into K2. What is K1? K1 being the air density correction factor and K2 being the humidity correction factor, where we have told that the breakdown voltage of the sphere gap is affected both by air density and humidity correction factor. So, K1 is the air density correction, K2 is the humidity correction factor to be considered. So, how to determine the K1 and K2? It is very clearly given in the standard 60-1, that is IEC 600601 or IS 2071, where K1 could be calculated as K1 is equal to P is the pressure divided by 760 to the standard atmospheric pressure into 273 by 20 by 273 by 20 degree by T temperature at the lab conditions. So, this will be equal to 293 by 760 into P by 273 plus T, where K1 will be equal to 0.386 into pressure by 273 plus T, where T being the ambient temperature, P being the atmospheric pressure in mm of mercury, mmHg. So, this is how the K1 is being calculated. Further, calculation for K2 is very important. This involves 2 steps, that is a 2-step process for calculation of K2. The step 1 is to measure the relative humidity. How to do that? We will discuss about it. So, first step consists of measuring the relative humidity, then measure the ambient temperature of the experimentation performed. So, going to the graph 1 in the standard, we could determine the absolute humidity, that is in grams per meter cube, absolute humidity in grams per meter cube, that is measure the relative humidity. This is the graph 1 which is being given in the standard, where it gives the values absolute air humidity in grams per meter cube in the y axis, and you can see the ambient temperature, that is a dry bulb temperature in the x axis. So, depending upon the values, considering both wet bulb temperature and the dry bulb temperature, you can see here, for example, if it is 20 degree and dry temperature and wet bulb is 18 degrees, you can go through this and see here, this corresponds to say 16 grams per meter cube example. So, similarly the values are calculated from the graph, and this gives grams per meter cube. This is the value of absolute humidity is obtained. Now, after that the step 2 is to calculate absolute humidity by K1 grams per meter cube. So, again we have to refer graph 2 to determine the K2. So, how do we do that? So, this is the K2, where the humidity correction factor for K2 is done. It gives the ratio of absolute humidity to air density in the x axis and humidity correction factor on the y axis. So, ratio of absolute humidity to air density is first calculated, that is absolute humidity by the relative humidity is calculated. From the graph we can determine the K2. From here this ratio versus the humidity correction factor suitably. So, in case if it is a 15 grams per meter cube, so 15 grams per meter cube, here it corresponds to say 1.04 or 1.05 is the correction factor for K2. These 3 curves shown here, the dark line is for the alternating current voltages, reference of that, and in case experiments are performed with impulse voltages, you can see a dot and a dash. This line represents the curve which is to be referred for impulse, and in case of DC voltages, this is the curve to be referred. So, in case of DC, a particular value say 15 grams per meter cube for DC measurement of the sphere gap used, then we have to focus on the DC curve where we get the value suitable to the DC level, and further the correction factor for K2 is obtained. This is how the factors K1 and K2 are obtained. So, finally, going back, so we have to determine the voltage V naught by Vm, V naught is equal to Vm by K. So, the K being K1 and K2, we have found out K1 and K2 now through the graphs. So, we can calculate the values which have been obtained. So, final voltage in equivalent with the standard conditions could be obtained, that is equivalent to the measured value by the factor K. So, very important for the measurements, the correction factor, incorporating the correction factor to the standard temperature and pressure values is very important while using the spear gap assembly.